The next layer of the derivative is in looking at like what does the derivative tell us? We're talking about concavity and an inflection point. So concavity is when we're talking about the second derivative. So concave up is visually when a graph looks like this, right? That would be representing concave up, and that happens when our second derivative is greater than 0. And then concave down looks like this, and that is when our second derivative is negative. And then when your second derivative equals 0, it's called an inflection point. And that's when you shift your concavity from one kind of concavity to another. So shifting from like a concave up to a concave down, somewhere that transition happens. And that inflection point is that point of when it happens. And that's when our second derivative is obvious. So our second derivative is going to be equal to 0. All right, so we're going to do first example, just kind of here's some descriptions of things. And then on the next example, we'll do some actual values. So let's try to figure out what kind of a graph or what sketch we could draw based on this information. So we have, what would it look like if you had a first derivative being greater than 0 and a second derivative being greater than 0? So the first derivative being greater than 0 represents that we would have a positive slope, right? The graph would be going up, right? So positive slope. Let's do this. So positive slope looking like that. And then this, our second derivative being greater than 0, means that it is concave up, which means it looks like this. But on concave up, part of the graph has a negative slope, part of the graph has a positive slope, and it kind of transitions right here. So that description would only be with a positive slope and concave up would only be this section right here. So a graph that would look like that would be something looks like that, right? That's the kind of graph that we would have. And then here we have a different example. So positive slope. Positive slope. With the first derivative being greater than 0, and then you have the second derivative being less than 0, so that's negative. So that is concave down. And so you have a positive slope and concave down, which would look like this. So again, just like concave up, you have this transition and the slopes. So you have a positive slope on one side of it and a negative slope on the other side of it. So the positive slope and concave down would be that section. So if we were to draw some sort of a graph to that, we would have something that looks like that. Right? That would be positive slope but concave down. All right, and then last little bit to this is which of the functions, the f of x function or the g of x function or g of t, the f or the g functions, could it describe a population that's increasing and approaches a steady state, right? So it has to be increasing. So both of these are increasing. So this one's increasing, but this one's starting to level off. That's the concave down part to it. So it's approaching a steady state. That's going to be our g. So g of t is going to be that. All right. And so that's just a little introduction to concavity. It's always talking about the second derivative is concavity. The first derivative is nothing but slope. Second derivative is nothing but concavity. In the next video, we're going to do some sort of an example that's going to mess with that.